Hi everyone, welcome to Google Developers Live. My name's Ali. I'm joined here today with Carrie and a special guest from our engineering office in Boulder, Brian Cairns, the lead engineer for the Realtime API. As you can see, I'm extremely excited to have him here with us. We're going to talk a bit about the Realtime API and then some features we've launched recently that will help you use it. So diving straight in, hi Brian. How are you doing?
I'm doing excellent, actually.
Awesome.
How are you?
Thanks again for joining us. So could you tell us a bit about the Realtime API? What is it? What problem does it solve for developers?
The real-time API is a way that you can add real-time data storage or collaboration to your app that works with Google Drive. So basically, you put a small piece of JavaScript code on your page, and we let you basically read and write from a data model that looks very similar to a local data model that you might use in JavaScript. And then all of that data gets automatically synchronized and stored in Drive and sent to any collaborators that may be on the document in real time.
Cool. So what kind of apps would use this?
So, I mean, you can think of sort of more traditional editor type apps. So if you're writing a code editor or a word processor or a project planning tool, this is a really great sort of API for productivity apps because you can have real-time collaboration that works just like it does in Google Doc Sheets and Slides. But there's also a lot of unconventional kind of uses. We've had people do games. We've had people use it just because they want to store user preferences or they want to store some sort of state that gets synchronized across multiple devices. So there's really a lot of different use cases in any app that can benefit from real-time data storage, where you're sending only the changes as they're made. And any app that can benefit from synchronization or collaboration is a prime candidate for the Realtime API.
Okay, that's awesome. What specifically about this excites you? Why did you get up one day and think, let's do a Realtime API?
So we actually started on the Realtime API a ways back. I don't know if you recall, but we first announced it at Google I/O in 2012. And the genesis of this idea was we had all this real-time technology for doc sheets and slides that is really, really cool from a theoretical standpoint. There's a lot of work that goes into making sure that all the conflicts get resolved properly and everyone ends up in the right state. And the idea was, well, we have this great technology, but we're only using it for these three apps. And of course, at Google, we want to have really great apps that we give to end users, but we also want developers to be really successful. And so the thought was, why don't we expose this technology to third-party developers and see what sort of apps they'll build with it.
Okay, awesome. Thank you. So can you tell me a bit about the feature we've recently launched and why that's a useful feature?
Yeah, so a new feature that we actually announced at I/O and just recently launched is import-export. So we've heard from a lot of developers that they like the real-time API, but they're a little bit concerned that it's not necessarily the easiest thing to get their data in or out of. And we want to be very, very clear that it's not Google's data, it's the user's data, and that developers should be able to get it out in whatever format they need. So this import-export API just lets you get a very clear JSON representation of a data model, of a real-time data model, and export that to your app. And it's very simple to use. You make a REST call to the server, and you provide us with an OAuth token. And it's actually integrated directly with Drive API. So if you use any of the Drive API client libraries already, you'll get this automatically. In some cases, you may have to download the library and recompile. But the fantastic thing about this, the format's stable. It's human readable, so you can go through and just look at what the document is. It's easy to process if you have any sort of application that can deal with JSON. And it works both ways. You can export and then modify the document and then re-upload it, and people will see those changes in real time.
So just to get that right, I can change the model outside the Realtime API and I can put it back in using your import, and everything will just magically work across all the users?
Yeah, so what we actually do is when you upload the model, we look at what is already on the server. And that could be the same thing when you downloaded it, or it could have been that plus a series of changes. But regardless, we look at the state of the model on the server and the state that you uploaded, and we take a diff of that, and we generate the mutations that are necessary to turn the current state on the server into the state that you uploaded, and then broadcast. We save all those changes, and then we broadcast them to all the collaborators. And if you want some more details on exactly how mutations work and all of the technical details there, the Drive Realtime API Secrets talk that we gave at Google I/O, myself and another engineer, Cheryl Simon, is a really excellent talk that goes really sort of on a technical level into how it works. But the cool thing about this diff approach is we preserve this, all the real-time nature of the system, even if you're uploading this JSON version. So if you upload a new version in JSON, and you have collaborators on the document, those collaborators see those changes immediately. They don't have to reload or anything like that. And perhaps even cooler than that, we can actually diff against any revision that you want. So let's say you downloaded revision 15, and then you're modifying it offline in your app. If there are other changes that are going on in the interim, when you upload, you can say, okay, don't diff this against the most recent version, diff this against version 15, and then apply only what changed between version 15 and what I uploaded. And what we end up doing is we take this diff and we get this set of changes, and then those get merged in with the changes that were made in the interim, and you end up with a document that incorporates both the changes you made offline and any changes that any other collaborators may have made in the interim. So this is a really fantastic way to do offline if that's something that you're interested in.
So that all sounds extremely crazy and insane how you managed to do that, but very cool. And I guess, that's why you use the real-time API rather than try and roll this thing yourself, because that's a very, very hard problem to solve. Would you say?
Yeah, I mean, there's a lot of work that goes into sort of decomposing everything you can do on the data model into these mutations. So any change you make to a real-time document gets represented as one of these mutations. And then to handle conflicts, we have to do this thing called transformation. And transformation basically adjusts mutations so that they take into account the effects of other mutations that may have occurred previously. And the thing is, the really hard part is for every different mutation type, you have to potentially transform it against every other mutation type. And so you end up writing, n squared transformation functions for your n mutations. And so as you add more and more features to the system, the complexity really explodes. But the great news with the real-time API is we've already written all these transformation functions, and it's all done and packaged in a way that's easy. You don't have to worry about transformation. You don't have to worry about these mutations even. You just read and write from the data model like it were a local application or a local in-memory data structure, and we handle all the rest.
Okay, thank you. Thanks for explaining that. So we launched the real-time API a few months ago, and people have been using it. What kind of problems have you had that you didn't really anticipate? Has there been any issues of scaling or anything crazy you've had to do to make it all work?
So scale actually is not really an issue. This is one of the benefits of being built on some of the same technology as Google Docs. There's been a lot of work there to make sure that we can handle any scale that's necessary. We had some issues early on where people were storing much more data than we anticipated. We anticipated that people would keep documents in the few megabyte range, and there were some developers who saw the API and really loved the API and decided to store 100 or 500 megabytes of data. And that's something we didn't anticipate, and we had some performance issues with load performance not being very good. And we did a lot of work to really optimize performance so that we can now handle much bigger documents. In fact, we have a limit now of 10 megabytes of data in the document. And that's done just to make sure the performance stays reasonable. But we do have plans to work on improving that. And our goal is basically whatever scale or whatever size you need, we want to provide. Now, I'm not saying that we're a great choice for storing binary files. If you want to store binary files, there's the Drive API for that. But if you have some sort of structured data that's large, that's certainly something that's a good candidate for the Realtime API.
Okay, great. You mentioned the binary case. That reminds me, I was actually talking to the CEO of Facebook who specifically asked me, when can I store binary files in the Realtime API? So I gave him the same answer as you, but anything you want to tell him?
Yeah, so the best way to deal with binary files in the Realtime API is to actually upload your binary file to Drive. And there's a lot of different places you can store it. You can store it in the root of their Drive, or if you wanted it to be application specific, we have application data folders that you can store data that's just for your application, and it doesn't pollute the user's Drive with lots and lots of entries. But once you've uploaded it to Drive, then you get the file ID back, and that file ID is universally unique. So you could put that just into the data model as a reference, and then when you're displaying the real-time document, you would go and retrieve that file ID and display the data however it's appropriate for your app. So this is really good if you have an app that you want to embed videos, or you want to be able to embed photos or any kind of media. If you actually want to collaborate on binary data, then we have a solution for this. Unfortunately, there's not any technology we're aware of that actually lets you collaborate directly on the binary data itself. But what we do offer is, if you initialize the Realtime API, when you call the load function to load the API or to load a document, you give us a file ID to load. If you give us a binary file ID, then we create this sort of hidden proxy document that you can do your collaboration on. And then when you're done with collaboration, either periodically or when the user goes to save, you can save those changes back to the binary file. And what this does is it basically lets you have collaboration on a binary file. The user, what they see is they open a file and they get this sort of real-time model. They don't know that there's this separate real-time model. They just know that they're working on this file. And then when they save, it gets saved right back to the file. And in fact, if you have multiple different editor applications, we handle that too. We handle all the sort of edge cases, and the documentation will walk you through how to do that. But you can get a really solid editor experience on binary files that are collaborative. And a lot of our third-party apps that use the Realtime API already do this, like Neutron Drive, for example, does it with source code files.
Okay, thank you. So while we've got you here, tell us any kind of secret plans for the future? Anything you can tell us? What are you working on at the moment?
So the current priority is to get a native Java API out. So right now we know that a lot of developers love the Realtime API, but they're developing for Android, or they maybe want to manipulate the data model on their own server. And the first step towards that was the import-export. So if you want to build a mobile app now or something like that, the import-export API is a pretty good way to do that. You can get the data out, modify it, and then save it back. But if you want the real-time collaborative experience on mobile, right now you would have to use the JavaScript API and do something like that. And we've actually had some developers who have worked with the JavaScript API on mobile. But clearly, what developers really want is a native client, something that's not going to be this sort of wrapped up JavaScript API. And so we're working on a native Java-based client that will work great on Android. It'll be very network efficient, bandwidth efficient, and it'll also work on any other Java platform. You can use it on a desktop if you have a desktop Java app, on the server if you want to do something there. And there's lots and lots of options with that.
Okay, fantastic. So you heard that here straight from Brian. That we're working on a way to allow you to do this on Java, desktop, server, and Android, of course. Right, thanks, Brian. That's really great, and thank you so much for joining us. That's really nice. I'm sure people will ask a lot of questions. They can send them to me or you, and we can follow up. If you've want more information about the Realtime API, we have our documentation, we have a quick start sample, and I think the most important thing we have is a mini client library that abstracts out things like authorization that you should use. It's the realtimeclient.js, and that's all linked from our documentation. So go and check that out. If you've got any questions, get back to me, Brian, or on Stack Overflow. Right, so now we have Carrie, who's going to take you through the app of the week.
App of the week.
Hi everybody, I'm Carrie. Today we are demoing Pixlr Editor, which is a really great photo web app to edit all of your photos that you have stored in Drive. So I've already gone to the App Store and installed this, and so if I'm browsing through my photos, I've come across one of my favorite dog, Zoe, and if I want to edit it, I can open it directly with the Pixlr Editor. So you can see that they've integrated with one of our access points here. So I will select Pixlr Editor, and so as this is loading, what's really great about Pixlr Editor, we have so many one of the main use cases for Drive is people store all of their photos in there, and we really want people to be able to interact with their photos in Drive, so this is a great app to allow you to do that. So you can see it's now loaded in my browser, and I have all of these tools available for me. A very similar set of tools that you would see in a like a web or a photo software tool. So let's see, I want to play around with the brightness and contrast. So I can go right here, and it's too bright. Let's make it, it's too dark. Let's make it a little bit bright, and let's saturate the colors a little bit more. And then there are a whole bunch of other things that you can play with. I can do the color balance. If I want more red, greens, and blues, I can add that too. And then if I wanted to crop my photo before I save it, I can do that as well. And if you know more about photo editing, there are lots of other great features here that you can play around with too. So I'm going to apply these changes. And then the great thing about this tool too is I can save it directly back to my Drive. So you can see here they have all these integration points. I'm going to save it to Drive and call it Zoe Dog Enhanced. And then when I go back to my Google Drive, I should see this new photo that I just created. So that's Pixlr Editor. We love to see apps that you guys are building. And that's all we have for today. So I wanted to thank Brian for joining us. Thank you so much, Brian. I know you're really busy. It's great to have the Eng team on our calls to hear more about what you guys are working on. And thanks, Ali,
Thanks,
for joining as well. And that's all we have for GDL today, but join us next week.